Hello students, today we are going to start again with the next topic under the modern periodic law. Before that we will do a quick revision. Okay. So, you know about the modern periodic law, which says that the physical and chemical properties of elements are periodic functions of their atomic numbers. Okay, so you can see these horizontal columns known as periods, they are 7 periods, and the vertical columns which are known as groups, there are 18 groups. Okay. So, group 1 are called alkali metals except hydrogen, since it is a non-metal. Group 2 is known as alkaline earth metals. Then comes group 3 to 12, or we can see 3b to 7b, including group 8b, 1b and 2b. They are known as the transition metals. Group 17, they are known as the halogens. Group 18, noble gases, okay, or inert gases. And then these in the group 3b of the 6th and the 7th period, there is the lanthanide and the actinide series, which are also known as inner transition elements. Okay. Now, let us see what is the merit of the modern periodic table. Now, it is based on atomic number, which is a more important fundamental property. Why? Because from the atomic number we get the electronic configuration, from which we get the valence electrons, okay, and the chemical properties depends upon the valence electrons. So, position of an element in the table is related to its electronic configuration. Then it shows regular changes in properties of elements in moving across a period and down a group, and it is easier to remember, understand and reproduce. Now, what are the defects? Position of hydrogen is still not satisfactory because its properties relate to both group 1, which has alkali metals, and group 17, which has halogens. So, still there is a controversy regarding the position of hydrogen in the periodic table, but still it is present in group 1 along with alkali metals, because like alkali metals it has one valence electron, okay, which it can easily lose. Then it fails to accommodate the inner transition elements, that is the lanthanides and the actinides, into the main body of the periodic table. As you can see, the lanthanide series and the actinide series, they are present at the bottom of the periodic table. If we place them here, it will distort the shape and size of the periodic table. Okay. So, these are the drawbacks. Now, what are the general trends in the modern periodic table? Now, let us come to groups. How many groups are there? 18. So, as we go down a group, what happens is that number of cells increases arithmetically. Okay. That means group 1 has 1 cell, group 2 has 2 cells, group 3 has 3 cells, and accordingly. So, let us see the halogens: fluorine, chlorine, bromine, iodine, astatine. Number of cells, you see, since fluorine is present in second period, number of cells is 2, chlorine 3, bromine 4, iodine 5, astatine 6. Okay. Then comes valency. Now, valency of an element equals the number of electrons present in its valence cell. Okay. Now, we know that elements in a particular group, they have equal number of electrons. That means they will have the same valency. For example, the valency of all the alkali metals is 1, because they have one valence electron. Okay. So, valency of group 3 elements is 3, because they are 3 valence electrons. Group 4, it is 4, because they have 4 valence electrons. Or we can do one more thing, group number 14, 4a is, according to the latest notation, it is group 14. Okay. So, what do we get? 14 minus 10 is 4. Similarly, valency of group 5a elements is 3. Why? because what is the group number? It is 15. Okay. So 18 minus 15 is 3. 6A elements, it is 2. Why 18 minus 16 is 2. 7A elements, it is 1. How? 18 minus 17 is equal to 1. In this way, what do we see? Valency first goes on increasing and then it decreases as we move from left to right in a periodic table. So, valency of group 0 elements is 0, 18 minus 18 is 0. Now, let us see properties of elements. Now, elements in a given group will show similar chemical properties. Why? Because chemical properties is dependent on the number of valence electrons, okay, and the number of valence electrons in a particular group remains the same. Now you see the example given out here. Alkali metals, they are all very reactive, okay, and degree of reactivity further increases down the group. So, if you see the alkali metals, when we move down, the reactivity goes on increasing, but it is the opposite for halogens. As we move down the group, the reactivity decreases, okay. Then what about the atomic size? As we move down the group, of course, it should increase. Why? Because new cells are added. Lithium 2 cells, sodium 3 cells, potassium 4 cells, rubidium 5 cells and so on. So, atomic size increases as we move down. What about the metallic character? It also increases as we move down a group. For example, in group 15, nitrogen and phosphorus are non-metals, arsenic and antimony are metalloids, and bismuth is a typical metal. Okay. So, it is on account of gradually increasing metallic character of elements from top to bottom that oxides of element become basic in character as we move down the group of a periodic table. As you can see, no, these oxides are acidic, nitrogen dioxide and phosphorus pentaoxide. Then comes amphoteric oxides, which shows the property of both acids and bases. Then comes basic oxide, and you know that hydrogen has been placed at the top of group 1. Why? Because it has one valence electron. Okay. So, now as we see, let us move to periods. Okay. Now, on moving from left to right in a given period, the number of cell remains the same. As you can see, the number of cell remains the same for a particular period. No, in the third period, the number of cell remains 3. Number of electrons in valence cell. So, in a given period, the number of electron in valence cell increases from left to right. For example, out here 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. Then comes valency. Valency also increases from 1 to 4 and back to 1. 1, 2, 3, 4, then again 3 to 1. Why? Because 18 minus 14 is how much? Sorry, not 14, 18 minus 15 is 3, 18 minus 16 is 2, 18 minus 17 is 1, which we have already discussed. Okay. Now, size of atom. Size of atom decreases when we move from left to right in a period. Okay. So, you see the size of atom goes on decreasing. It is because the number of proton goes on increasing, which increases the nuclear pull. Nuclear pull is the pull of the protons on the outermost cell, and the cell comes close to the nucleus. Hence, alkali metals have the largest size and halogens have the smallest size in a particular period of the periodic table. Then comes properties of elements. Now, properties of element depend upon the number of electrons in its outermost shell. Okay. So, what will happen? Properties of elements in a period will differ, because what happens? The number of valence electron differs. So, reactivity first decreases up to group 14 and then increases. Okay. So, as you can see here, group 1 elements are the most reactive and group 17 elements are the most reactive non-metals. Then comes metallic character. As we move from left to right, what will happen in the metallic character? It will decrease and non-metallic character will increase. See here, elements of the second period. Lithium and beryllium are metal, boron is a metalloid, carbon, nitrogen, oxygen, fluorine are non-metals, and neon is an inert gas. So, what about the oxides of elements? Oxides of elements of a particular period becomes less basic and finally change to acidic character as we move from left to right of the periodic table. Why? Because the metallic character goes on decreasing. Okay. Thank you.